Hello, everyone, and welcome to this episode of Crowded Beaker Solves. Today, we're going to be drawing the second in our series of Lewis structures, which are drawings of molecules, diagrams of molecules to try to show the structure. And it shows which atoms are attached to which and where the extra electrons might go and how the bonds are arranged. And so, we're going to start by looking at our prompt, which has this, in this case, sulfur tetrabromide, SBr4. And I'm just going to go ahead and write the formula for that, SBr4. I like to do that so I can organize my total number of valence electrons. Now, in my last video, I said you should look at the column of the periodic table that it's in to get the number of valence electrons, because the total, you have to get the total first to find out how many valence electrons you're actually dealing with. So there's two columns over here that are not shown, but six over here for a total of 8. Sulfur is in the sixth one, which means that it has 6 valence electrons, 2 in the S, 4 in the P's. And bromine is over here in column 7, so it has 7, and there's 4 of them, so I have to multiply that by 4. That's 28 plus 6 is 34 electrons. This is the pool of electrons that these atoms have to work with, and we want to arrange them in the molecule so that they work out for the best. All right, so then what we're going to do is put the sulfur in the middle and the bromines around the outside. Give them all a single line representing a single bond. Now I've used up 2, 4, 6, 8 electrons because each of those lines represents 2 electrons. Then we're going to start on the outside and give them all an octet. That means giving them 6 more each. Now you do this, you may end up having to remove them or move them around later, but just start by giving them all 6 as long as you have enough. Now in this case, now I've used up 32 electrons in this structure, 2, 4, 6, 8, and we do that 4 times, that's 32. I have 2 more to go. That's what my total is. So this group of atoms got a couple extra electrons, and the rule is to put them on the central atom. Keep them in a pair, make them close together, but stick them on that central atom because that's where they're going to go. Even if doing so results in the sulfur having more than an octet, as we said, the octet rule is more of a suggestion than a rule. It likes to be an octet, but it can have more. The sulfur in this case is taking 1 for the team and taking 10, and the bromines are left with their octets of 8. And that means this molecule has 4 bonds and a lone pair for a total of 10. And we'll talk more about the geometries of those in another episode, but that would be a correct Lewis structure for sulfur tetrabromide. All right, now it's your turn to follow the same steps, and this is a similar molecule. Not exactly, but similar. And the prompt here is draw a Lewis structure for iodine trifluoride, which has the formula IF3. So take a moment, pause the video, and see if you can draw IF3, and we'll come back in a second and see how you did. Okay, so once you're done drawing your IF3, hopefully it ended up looking like this. Similar to the other one, except there's only 3 atoms around it. And you should have found there was 28 electrons, 24 get used up here, and you have 4 extras, so there's 2 pairs of dots that need to go on that central atom. Just put them there, don't even think about it. The rule says put them on the central atom, go with it. And, as long as you don't question that, you should be doing pretty well. And this molecule ends up having 3 bonds and 2 lone pairs instead of the 4 bonds and 1 lone pair that I had before. But they are similar and they follow the same rules. So there you have it, another couple of Lewis structures for you to consider. If you have a suggestion of a Lewis structure you'd like me to draw, you can send it to me. Otherwise, in the meantime, happy drawing and have a great day.